This week, we will continue and hopefully finish our discussion about inheritance. It's been 2 weeks already and we have learned quite a lot about this topic. Just to recall, we actually learned about static type, dynamic types, polymorphism, dynamic binding, expectation, rules of substitution, what is safe and what is unsafe, typecasts, and also class cast exception, and also finally the instance of operator. So these are so many dots that should be connected all together, and you really want to tell a convincing story to yourself before you can actually apply all the concept to real world problems. And for this week, we're going to continue with a similar discussion and then see two to three more applications, and then we'll move on to some related topics as well in the later part for this week. All right, let's now start with the first one. Just to warm up a little bit, I would like to just do a few more examples related to static types, casts, and also polymorphism, especially what kind of a method call can you really make based on the declaration of a reference variable. And I want to start with 4 little exercises together with you. You can definitely look at the slides to see the rationale for each of the solutions, but I would like to switch to iPad just to go over the exercises quickly together with you. If you have already understood our discussion from the earlier week, then you should be able to do them without any trouble. But let's take a look together just to review. Let's now assume that we actually got this part over here. We got this hierarchy for the smartphone, and this is only part of the implementation in Java based on the hierarchy diagram. Only part of it, not all of it. For example, you can see we got a smartphone over here. Let me just highlight it quickly. You can see here we got a smartphone, which correspond to the smartphone over here. And we got iOS, which correspond to the iOS over here. And also we got iPhone 13 Pro, which correspond to this class over here, right? And then we also have to make sure we implement the inheritance relation or the extents relation properly. So you can see this is one. iPhone 13 Pro inherits iOS. So you can see that's exactly the extents that we are trying to implement over here. Also, iOS extends smartphone over here, and that's exactly the extents that we are implementing over here. And as I said before, it would be a very valuable exercise for you to actually complete to really try to build the inheritance hierarchy, everything into classes in Java. So this is only showing you some small example. You should really do that by yourself, and then you will be able to reproduce all the examples we did earlier and try to see if there's any compilation error or if there's any class cast exception at the runtime. That's something you definitely have to do. You have to do it on your own in order to really understand and then remember. All right, let's now take a look at the example. And you can see for the smartphone over here, we got dial corresponding to here. And also we got FaceTime in iOS corresponding to this new method right here. That's like an extra expectation in the subclass over here. And also we got a quick take, which corresponds to this extra method in this descendant class over here, right? Everything still makes sense. Let's now take a look at this fragment of code. So let's now talk about compilation. I want to know if each of the lines over here will compile, right? Let's now take a look at the first one. The first one here, you can see the smartphone is declared as a static type for SP over here. So smartphone is the static type, right? Let's also make a quick notes over here. So this is declared to be the static type. And what about the dynamic type over here? Well, it's on the right hand side after the new keyword. So that's one of the ways that we can change the dynamic type. The other way is by doing some reference variable assignments. iPhone 13 Pro. So that's the dynamic type, which is over here. And now we want to ask whether or not this particular substitution will be valid, right? Is it valid? It turned out it is valid because this is actually a descending class of the static type, which is over here. Meaning that this dynamic type can fulfill all the expectation on its ancestor class, which is smartphone, right? So this is really important for you to know. You should definitely be able to judge quickly, and also if you are asked to write down some detailed justification, you should also do that, right? So you should say iPhone 13 Pro can fulfill the expectations of smartphone. More specifically, that's also for the answer to be complete. iPhone 13 Pro over here is indeed the descendants, whereas the smartphone over here at the higher side of the hierarchy, so that one is the ancestor, right? So that'll be the complete answer. You want to actually mention both parts. All right, so that's line number 1. So line number 1 indeed will be valid, will compile. So that's why if you reval it, that'll be a check mark. All right. What about line number 2? Line number 2, 3, and 4, we are using SP as a context object. Let's note that. Note that first. You can see SP is being used as the context objects. So what can we put after the dot? Right. That's an important question over here. And we talk about. Let me do it again. And we talked about it before since the very beginning of the discussion for inheritance. So that will depend on the expectation on its static type. And in this case, dynamic type is not relevant. So the expectations is only determined only is important by the static type, which is smartphone over here, and dynamic type here is simply not relevant. Okay, so we don't even consider that, right? So there's going to be dial and surf web. So these are the only two expected methods that we may call at the runtime, at the compile time as well. So dial and FaceTime should be okay. And what about quick take? Quick take is definitely not part of the expectation for smartphone, even though the dynamic type is. So remember we said before, the dynamic type is not cannot be inferred by the compiler because it's an undecidable problem. Remember the A+ challenge I posed to you. I hope you haven't tried. Okay, it's simply not going to work. Right, so in this case, so these two will be okay if they are part of the expectation for smartphone, but not for quick take. It is not. It's only the expectation on the lower descendants of smartphone, so not at this level. So that's why you're going to see yes, no, and no. Oh, I said something wrong here, sorry. So you can see the FaceTime over here is also the expectation for iOS, right? I didn't see that. I thought it's a surf web, right? So FaceTime and also quick take. So these are simply the expectation of the descendant class, like a proper descendants, like a child and child's child over here. These two, they cannot be expected on smartphone. All right, that's the first exercise, right? And the next two will be very similar. I'm going to leave the next two exercises actually to you. All right. For the next two, let me just sketch very quickly about how you can solve them. Okay. Basically, you're going to look at what's the static type. In this case, it's going to be iOS. And we're still talking about the three classes over here, right? We're still talking about these three classes, the same as exercise number 1. So for exercise number 2, realize it's actually iOS over here as the static type, meaning that when you talk about IP over here, you should only try to look at its static type to determine the expectation, right? And for the answer, you can solve that by yourself on a piece of paper, and then you can see the answer from the slides. All right, that's exercise number 2. For exercise number 3, also similar, and now this time we are trying to do the static type as iPhone 13 Pro, right? You can see this time we are trying to make it more specialized, like a lower in the hierarchies static type, which is just the same as dynamic type. For all the 3 exercises, you can see the dynamic type is just the same over here, but the static type can be just different. As long as the static type is an ancestor of the dynamic type, its expectation can just be fulfilled by the dynamic type. That's something we kept emphasizing since last week. All right, for this one here, all you got to do is you're going to make sure you know whether or not the method that's being called is actually can be expected by the static type over here, right? So that's exercise number 3. I'll let you do it. The final one, I'm going to do it together with you because that one is going to involve some casts. So I really want to recap from last time very quickly about the typecast. Right, we still got these 3 classes. Let's now try to annotate the diagram. Static type is smartphone. Okay, so this is the static type. Okay, let me write it down. And since it actually involves the cast, you have to talk about 2 separate issues. One is whether or not it compiles. Number 2, if it compiles, are we going to have class cast exception at the runtime? So this is the static type. All right, and then what we have is dynamic type at the right hand side, and this one apparently is a descending class of smartphone, so it can fulfill its expectation as we said before. So I'm not going to write it down again. And this one here is simply the dynamic type. So now you should know about the 4 categories of the typecast, right? Like which one should be compilable, which one should not be compilable, and also which one should give you class cast exception and which one should be not, right? That's something we also talked about last time. And let me just tell you, this is going to be valid, and you should know how to justify. Let's now try to look at the anonymous cast that we're doing. So you can see this part here, this part. What we're doing is, you can see this part, we're saying that we are trying to cast the variable SP. That's what we are trying to cast over here. So this is what we are trying to cast. Okay, let me just annotate it quickly. So SP over here is the reference variable being cast. Right, the way you can think about it is SP is actually pointing to some iPhone 13 Pro objects over here, dynamic type, right? Dynamically. It is pointing to some iPhone 13 Pro objects over here. iPhone 13 Pro objects over here. And I'm just gonna omit the details about the attributes. Okay, it's not really specified in the diagram. And then its static type for SP is actually smartphone, right? It's also important to note. Okay, let me just highlight better. So that one is going to be smartphone. Let me ask you this. If I say SP dot QuickTake, we know that it's not going to work because QuickTake is not supported by smartphone. Can we say SP dot FaceTime? Also, we cannot because FaceTime is not supported by its static type smartphone, right? That's something we know from the earlier exercise. But now, given that the dynamic type is really an iPhone 13 Pro, so you really should be able to support these two features, these two methods. And the only way to do it is by using the cast, right? So that's why we are trying to do anonymous cast over here, just without some variable to assign to. So let me write it down as well. So this part here, let me use purple, okay? So this part over here is the cast. What you can think about is a cast type. All right, so now we want to talk about 2 things, okay? 2 things, let me just review that. One is compilation of the cast. And number 2 is about, are we going to get class cast exception at the runtime? Okay, so these are the 2 questions. Let's answer one by one. For compilation, it's going to be okay if we are doing either upward casting or downward casting with respect to the static type. So you can see here we are trying to cast SP, static type smartphone, into iPhone 13 Pro. So that means we're doing downward casting, so that's okay, right? So here it's going to be okay. So this is valid, or it will compile, because it is actually upward cast. And it's important to say with respect to, sorry, not upward, downwards. I really meant the other way when I actually said it. Downward casting, right? We are trying to do downward casting this way. Okay, that's downward casting. So downward casting. So downward cast with respect to the static type. Again, we are trying to cast into iPhone 13 Pro, and that one there with respect to smartphone, the static type is really indeed downward casting, right? So that's number 1. What about number 2? Are we going to get class cast exception? We will get into class cast exception if the dynamic type cannot fulfill the type that we are trying to cast into, the cast type. So in this case, let me write it down. So basically, what you should really ask yourself is, can the dynamic type fulfill the cast type? That's the critical question that we kept asking. Of course, you can use the instance of operator check if you wish. So now in this case, dynamic type is iPhone 13 Pro, and the cast type is the same, iPhone 13 Pro. Let me just highlight it. That's also the cast type. At the same time, just happen to be the same, which is absolutely fine. Also happens to be the cast type. So now the question is, can dynamic type iPhone 13 Pro fulfill the cast type, which happen to be iPhone 13 Pro, right? Dynamic type iPhone 13 Pro, can it fulfill the cast type iPhone 13 Pro? The answer is yes, right? So that's why it is going to be exception free at the runtime. So that's also whether or not we're going to get class cast exception. The answer is no, we're not going to get it. All right, so these are the two questions what you want to answer by yourself, right? And one more thing, okay, that's also very important. So we just talk about compilation, we talk about the cast, so everything's going to be fine. But what about making the method call over here? Are they going to be valid? Are they going to compile? You got to think about the type of the expression. I want you to think about this part over here, right? We're trying to use the parentheses over here, parentheses and parentheses, right? This part over here, when we try to cast the SP into iPhone 13 Pro, what's the static type of the resulting expression? It should be corresponding to the cast type. If you refer back to the anatomy diagram for the class cast syntax, you will see that, right? That's also very important for me to highlight. So let me use maybe, I think pink should be okay. So now I want to highlight this properly. Okay, you can see I want to do everything into here. Okay, you can see that one includes the parentheses surrounding the class cast over here. Okay, let me just make a note over here. So this one here, the cast expression has static type matching the cast type. Matching the cast type. Right, so this is really important for you to know, right? Cast exception. Oh, sorry, cast expression. Cast expression has the static type matching the cast type over here, which will be iPhone 13 Pro. So now, when we got iPhone 13 Pro as the static type, that means we can expect anything that's actually accumulated into this level over here, iPhone 13 Pro, right? What would that be? Well, it's going to be all the methods accumulated along its ancestor path. It's going to be QuickTake, FaceTime, Surf Web, and also Dial. So that's why all these are going to be valid. If you reval it, you will see exactly the answer. Check, check, and check. So these four exercises really can, in a way, also put together again all the things that we have learned from the previous part of the previous discussion about the inheritance. Please review these four exercises very carefully, right? That will also help you. All right, I think I got one more example to show to you very quickly, right? So these are the 4, 1.1, 1.2, 1.3, and 1.4, right? We have already discussed them. Let's now talk about one more thing. This is a principle I want to revisit. Given a reference variable declaration over here, static type of reference variable is class C, right? That's a declared type, right? We have seen many examples already. And whenever you want to make a method called v.n, right, where v is of static type C, what can you call as n? All the methods that's accumulated into along the ancestor path of C, like what I just illustrated to you. And its dynamic type is simply not relevant, right? Whenever you want to judge to see if a method call it's compilable, you only look at the static type. If you're certain about the dynamic type, you can definitely try to do instance of check and before you do a cast, right? That's also something we spoke about. Let me just go over one more example together with you. I can also review the instance of operator quickly. Let's now take a look at this. Okay, I'm not going to visualize too much, but I want to see this. Let's say student S, you can see the static type is students over here. And you can feel free to actually make your own example, maybe using the smartphone example. Okay, it's the smartphone hierarchy. Dynamic type is resident students over here, right? Let's make notes very quickly to really help you. This one is static type, and this one here is dynamic type. Okay, and we can do register and etc. Right? So that's how we visualize it. Static type, dynamic type. Now I want to talk about the instance of over here. Right? You should really you should really review the syntax for instance of. But let me just go there directly. So when we say as instance of some class name, right? This part here is always this part. Let me say it again. This part here, the right operand for the instance of operator is always a class name. And what does it check, right? The whole thing over here is only going to be true if, before I tell you the answer, why don't you pause the video and tell me what does it really mean when I say as instance of as instance of resident student evaluated true. What does it really mean? Pause the video and tell me the answer, even though I cannot hear it, but at least you should tell me. All right, assuming that you thought about it. Okay, so this part here, true only if the dynamic type of S, the variable, can fulfill the expectations of the right operand, resident students. Of course, we also spoke about last week about there are two ways for you to check this. Either you can check that dynamic type is actually a descendant class of this resident students, or you can say this resident students is an ancestor class of the dynamic type. Either way is okay, right? So here, this is resident students. Let's now use a different color to actually see. So this part here is resident students over here, right? Which happens to be the same over here. So this is the type to check for instance of. So now the question is, can the dynamic type resident students fulfill the expectation of resident students, which is the same class? Indeed, because a class is the descending class of itself. So definitely it is possible. After that, you can definitely do the cast. You can see here we're also again doing anonymous cast. Right? Let me just annotate it. And this one here, I think I can just do this. Okay, this part here, I just want to remind you, it's so important to actually know that. Okay, so this part over here, let me just try not to cross any line. Okay, let me do one more time. Okay, so this part here is anonymous cast. And what's going to be the static type of the expression? The cast type of static type resident students over here. So now that's why this will compile. Set premium rates is definitely part of the expectation for resident students, because you can see set premium rates over here. All right, final question here. When we call get to tuition over here, which version of the get tuition are we calling? Right? Before I say that, let me just annotate once more. This anonymous cast is basically some link without a name, right? It's going to be a link. It's going to be a link. Let me use blue. So it's going to be resident students. You want to cast S into resident student. It's an anonymous cast. That one is really a link that's actually pointing to the same objects over here, right? So when you try to say this anonymous cast over here, right? Let me just highlight again. So this part over here, you're trying to invoke the method on that, right? This part here, which version of the get tuition will be invoked over here depends on what's the dynamic type of the object that's being pointed to by this anonymous cast, which will be resident students over here, right? So that's why it's going to invoke the resident student version using premium rates. Dynamic binding is going to ensure the version of resident students will be invoked, right? It's a really important concept for you to also recall. All right, so that's about this exercise over here. So we kind of show you again anonymous cast and also what's the static type of any class cast expression. Okay, let me go back. All right, so that's about the first part I would like to talk about this week. Let's now move on to the next part, which is about polymorphism in the context of method parameters.